the book 3, which is the prisms and the cylinders. All of the topics related to this are the lateral areas, total lateral areas, and volumes of a polyhedron. But before we go to that, let us all know what is a prism. So Jubilin, what is a prism?
Prism is a polyhedron bounded by a prismatic surface and two parallel plane sections cutting all its elements. A prism are three-dimensional closed surfaces. It is also called polyhedra since their faces are polygons. A good example to this is a triangular prism. This is called triangular prism because its right section and its bases are triangles.
A cylinder came from a Greek word kalendros, which means a roller and a tumbler. A cylinder is one of the most basic curvilinear geometric shapes. The surface formed by the points at a fixed distance from a given line segment, which is the axis of the cylinder. This perfume here is the best example of a cylinder.
So, Chell, how is closed prismatic surface generated?
Okay, given a convex polygon and a straight line not in its plane, if this line here moves so as to remain parallel to itself while it touches the boundary of the polygon and made to traverse it completely, then this line is said to generate a closed prismatic surface. This moving line here is our generator, and the generator in any position of its is an element of the surface. So, we now know how a closed prismatic surface generated. Let's now proceed to the parts of a prism. Here, I have a triangular prism. And this triangular shape here is called the base. And this is also a base. These bases are two parallel cross-sections which bounded a prism. A cross-section of a geometric solid is the intersection of a plane and the solid. A prism has the same cross-section, which is parallel to the base, all along its length.
In this right triangular prism, these sides are called the lateral surface of a solid. This lateral surface is the face or surface of the solids on its side. That is, any face or surface that is not a base. So these are the lateral surfaces of a triangular prism. Okay, let's now go to the edges of a prism. The edges are the lines in which its lateral faces met. The edges are congruent and parallel. In this right triangular prism, these lateral faces met in a straight line, which is the edge.
Okay, let's now proceed to the right section. A right section of a surface cuts all the edges at the right angles. I have here a right triangular prism. This is our right section because this will cut this edge in a right angle.
Okay, let's go to the right prism. A right prism is one whose bases are right section. And a right section, as said by Rachel Grace, cuts all its edges at right angles. So in my example, which is a right triangular prism, this triangular prism is a right prism because the bases are right section.
Corollary number 1. All lateral faces of a prism are parallelograms. This figure I'm holding is a rectangular prism. It is called a rectangular prism because its bases are rectangle. And as said in Corollary 1, all its lateral faces are parallelogram. Why? Because its lateral faces of this figure are rectangle. The characteristics of a rectangle are, it has 4 right angles. This angle here, this angle here, this angle here, and this angle here. It also has two opposite sides are parallel. Now, this side here is parallel to this side, and this side is parallel to this side. It also has two opposite sides congruent. This side here is congruent to this side, and this side is congruent to this side. And its diagonals bisect each other. This diagonal here bisect this diagonal here. The characteristics of this rectangle are also the characteristics of a parallelogram. Therefore, this lateral face is a parallelogram.
Our second prism is a triangular prism. This is called so because all its faces are triangular in shape. So this first base is triangle and the second base is triangle. This prism has three rectangular faces. So these are the three rectangular faces of this prism. A rectangle is any quadrilateral with four right angles. So it has two opposite sides which are parallel. So this side is parallel to this side. And also this side is parallel to this side. It has also two opposite sides congruent. So this side is congruent to this side and this side is congruent to this side because they have equal length. It is also an equiangular quadrilateral since all its angles are equal to 90 degrees. So this angle here is a right angle which is 90 degrees. And this angle is also a right angle which is also 90 degrees. This angle formed here is also a right angle which measures 90 degrees, and this angle here is a right angle which is also 90 degrees. And this rectangle can also be defined as a parallelogram since it contains a right angle which measures 90 degrees. Those characteristics that I said is also the characteristic of a parallelogram. Therefore, these rectangular faces are all parallelograms.
Corollary 2. The lateral edges of a prism are equal and parallel. First, what is a prism? When we talk about prism, it is a polyhedron bounded by a prismatic surface and two parallel plane sections cutting all its elements. Now, I have here an example of a prism. This one. This is what we call a rectangular prism. These are the faces or the lateral faces of a rectangular prism. And this side is the bases. Now we need to prove that the edges are equal at the same time parallel. This is the edges of these lateral faces. We will name this as line 1 and this one as line 2. Now we need to prove that this line 1 and line 2 are equal. We will use a ruler to measure it. Alright, here we go. For our line 1, okay, here. It measured 8 inches. We will move to our line 2. Here, it also measured 8 inches, meaning to say these two lateral edges are equal with a measure of 8 inches. Next is, we need to prove that line 1 and line 2 are parallel. By definition of parallel lines, that when we talk about parallel lines, these are lines which do not meet. And in order for us to prove that these two lines are really parallel, we need to measure the distance between the two lines using again the ruler. Okay. At least 2 or more. Okay, here we go for this is our line 1 and line 2. Okay, here. So it has a measure of 5 inches. We will move here. Okay. Alright, it's still a 5 inches. So, this line and this line are parallel. Therefore, corollary 2 is true. Corollary 3. The lateral faces of a right prism are rectangles. I have here an example of a right prism. This is a rectangular prism. Now it has a faces, this one, this one, this one, and this one. And it is said to be rectangles. It has a basis, this one and this one, which are squares. Now, first of all, what are rectangles? When we talk about rectangle, it is a parallelogram with 4 right angles. Now, we will use one example of the face of this prism in order for us to prove that this is really a rectangle. Alright, by the use of a protractor, we will measure the angles of this face. Alright, this one. Alright, okay. As you have seen here, it has a measure of 90 degrees. I will mark this sign, which means that it has a measure of a 90 degrees. Next one is this angle. Alright. It also have a measure of a 90 degrees. Okay. This side, still 90 degrees. And lastly, alright, still 90 degrees. Alright, so we have here already the measures, which has a 90 degrees with a total of 360 degrees. Now, what are the properties of a rectangle? The properties of the rectangle is that all the properties of every parallelogram. And what are these properties? First property is that both pairs of an opposite sides are congruent. So in this example, we will name this as our side 1 or line 1. This one our line 2. Now it says that its pairs or the opposite sides are congruent. Using the ruler, we will measure if these two sides are really congruent. Alright, this one. Okay, our line 1. It has a measure of 5 inches. For our line 2, still, it has a measure of 5 inches. Meaning to say that these two sides are congruent with a measure of 5 inches. Next is, both pairs of opposite angles are congruent. We already measured, so this angle is 90 degrees and its opposite is also 90 degrees. So it is congruent because it has a measure of 90 degrees. At the same time, this one has a measure of 90 degrees. At the same point, this angle is 90 degrees and its opposite is also 90 degrees. Alright. Lastly, consecutive adjacent angles are supplementary. When we talk about supplementary, it has a measure at 180 degrees. And this angle are supplementary. So this has a measure of 90 degrees. And this one has also the measure of 90 degrees with a total of 180 degrees. Next is this one and this one are also adjacent. So it has a measure of 90 degrees and this one 90 degrees with a total of 180 degrees. Therefore, the lateral face is a rectangle because it all contains the properties of the rectangle. At the same time, corollary 3 is true. Kinds of prisms. Prisms are classified according to the form of their sections as triangular, quadrangular, and many more. Now, when we talk about prism, it is a polyhedron bounded by a prismatic surface and two parallel plane sections cutting all its elements. And what is this right sections that they are talking about? When we talk about the right section of a prism, it cuts all its edges at the right angles. Now, Now I have here some figures, and these figures are what we call a polyhedron. And we talk about polyhedrons. These are a geometric solid whose boundary consists of plane polygons. Now in these figures, we will classify which one are just polygons and which one are polygons at the same time a prism. Alright, now this one, this one, this one, and this one are considered to be polyhedrons but not a prism. But this one and this one are considered to be a polyhedron at the same time a prism. Because like what I have mentioned earlier, that when we talk about prism, it has a right section in which it consists a edges which are perpendicular to each other. So we need to prove that this one is really a prism. So like what I have mentioned, that we need to measure the right section. So I have here a protractor. We will measure these edges, this angle here, at the same time the angle here, in order for us to make sure that these are really perpendicular. So perpendicular, it should have been that the measure is a 90 degrees. Alright. Here we go. So using the protractor, we measure this edge. Okay. So obviously it measured 90 degrees. We will use this symbol as a sign that it measures 90 degrees. And this one, we will measure also. Okay. It still measured 90 degrees. So these edges are perpendicular and this is a prism. Now what is a regular prism? When we talk about regular prism, it is the one whose right section is a regular polygon. And what is this regular polygon? Regular polygon is said to be irregular if all angles are equal and all sides are also equal. Now, using again this example, the cube, we will measure all its angles if it all measured 90 degrees. So, using again the protractor. Okay, this one. In this angle, measured 90 degrees. Alright. Now, if it measured 90 degrees, its opposite also 90 degrees. Same time, this one opposite 90 degrees, right? Alright. Again, this one still 90 degrees. And since it is supplementary, then we could also consider it as 90 degrees for its totals of 90 degrees. So this is right angle at the same point, the same with the other, okay? Here. Alright. See, this cube has a measure of 90 degrees in each of its angles. So all its angles measured 90 degrees. But we also need to prove that each sides are congruent by the use of a ruler. Here it goes. So this line has a 3 inches. This line is also 3 inches. Here, still 3 inches. Here, still 3 inches. And all of these sides measured 3 inches. So, therefore, this cube is a regular prism.
Statement 171. Altitude and area. The altitude of a prism is the perpendicular distance between the planes of its bases, and the altitude of a right prism is equal to its edge. We take this cube as our example. We are to find the altitude of this cube. A cube is a right prism because its bases are right sections. So, the altitude of this cube is equal to the edge, and we'll measure one edge. it is exactly 3 inches. So, altitude is equal to 3 inches. Then, for the lateral area of a prism, lateral area is defined as the sum of the areas of its lateral faces. So, in this rectangular prism, we will solve for the lateral area. The lateral area here will be the sum of these faces. This is rectangular here, 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 here. We have to find their area and sum up the 4 areas of the rectangle. Okay. Since the lateral faces of this rectangular prism are rectangles, we can use the formula length times width, then add the 4 rectangles to find the lateral area. Or we can also use the given formula in the book, which is S is equal to HP. And first, in finding our lateral area, we will use the traditional formula, which is the area of a rectangle is equal to length times width. And since there are 4 rectangles which are equal, we will multiply it by 4. So, let's substitute. Lateral area is equal to 4 length times width. Then let's measure the length and the width. The length of this face is 8 inches. And the width of this rectangle is 5 inches. So, this will be 8 times 5. Then 4 times 40 inches. This will be inch squared because we inch times inch is equal to inch squared. Our lateral area will be 160 inches squared. And for the given formula in the book, we'll use S is equal to HP. S means the lateral area. So it seems like it is a representation or variable of the lateral area. Then H will be the length of the edge, the lateral edge. Then P will be the perimeter of the right section. And so it means that S is equal to, this will be our H, 8 inches. Then we have to take the perimeter of this base. The base is a square, so 5, 5, 5, and 5. This will be 8 times the perimeter, 4 times 5. This will be 8 times 20. And so this is 8 inches times 20 inches. It will be 160 inches. So whatever formula we choose between the two, they will result the same. So the lateral area of our rectangular prism is 160 inches squared. 160 squared inches. time, we are to find the total area. And the total area is defined as the sum of its lateral area and the area of the two bases. So, the sum of this lateral area and the sum of the two bases. Our total area, TA, total area, is equal to the lateral area or the S plus the the area of the two bases. Area of the bases. Then, we will substitute the value of our lateral area, which is the 160 inches squared plus the two area of the bases. For us to find the area of the bases, since it is a square, we are to measure its sides. 5 inches, 5 inches. Because the formula is S squared or side squared. So 5 squared inches. Then 160 inches squared plus 2 times 25 inches squared is equal to 160 plus 50 inches squared. The total area is equal to 210 inches squared. Statement number 172. Truncated prism. A truncated prism is a polyhedron which is a part of a prism cut off by a plane meeting all its lateral edges but not parallel to the base. Okay, here, this is a rectangular parallelopipe, but we let a plane pass through it, cutting all its lateral edges. So this will be the result. And this plane is not parallel to the base. To measure this, to prove that it is not parallel to the base, the measure of the lateral edges touching this plane should not be equal. So this edge measures 4 inches and the other 3.5 inches. This is 6 inches and this last edge is also 6 inches. The 4 edges are not equal. It means that this plane or this plane is not parallel to the base, and this is an example of a truncated prism. Okay. Two polyhedrons are said to be added when they are placed so that face of one coincides wholly in part with a face of the other. Okay. So this can be added because this plane coincides wholly to the plane of the other polyhedron. Statement 173 about parallelopiping. A parallelopipe is a prism whose bases and as well as the lateral faces are parallelograms. And we know that a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Then, we take this rectangular parallelopipe. A rectangular parallelopipe has its bases and all its faces rectangles. This is a rectangle. And what are, this is a rectangle. And what are the properties of a rectangle? The properties of a rectangle is it has four angles, it is made up of four right angles. Then the diagonals are congruent. Then it contains all the properties of every parallelogram. And what are these properties? Both pairs of opposite sides are congruent, which we measured earlier. Then both pairs of opposite angles are congruent. This is a 90 and 90. And consecutive adjacent angles are supplementary. They are both 90, so it is supplementary because if we add the two angles, it will result into 180 degrees. Then the diagonals bisect each other. And we wonder why that the bases or the right sections of this parallelopipe are squares. So let us define a square. A square is a parallelogram with four right angles and four congruent sides. So it means that a square is a rectangle. So this is a rectangular parallelopipe which is made up of all rectangular faces. The next, a cube. This is our cube. A cube is a parallelopipe whose bases are all squares. And as I have stated earlier, a square is a parallelogram with four right angles and four congruent sides. Four congruent sides because if we measure this, it will result into 3 inches, 3 inches, 3 inches, 3 inches, and so on and so forth. And the properties of a square is a square has all the properties of every parallelogram. A square has all the properties of a rectangle, so a square is a rectangle. A square has all the properties of a rhombus. And a square is a parallelogram, a rectangle, and a rhombus.